Hey guys, we're Block 3 AP Chem class, and we're here to talk to you about dimensional analysis. But what is dimensional analysis?
Well, Hugh, it's using units and conversion factors to get from what we know to what we need to know.
Our videos on dimensional analysis and the included practice will help making learning it a breeze. And we hope you'll check out our videos and in the end learn something about dimensional analysis. Now, to explore the concept of dimensional analysis, let's take a look at the problem 5 over 1 times 27 over 5 times 4 over 9 times 10 over 3 times 9 over 27 times 3 over 10. In dimensional analysis, you will be using units and canceling similar units to convert. In this problem, to explore that concept, we will cancel similar numbers. So here we can cancel out 5 in the numerator, 5 in the denominator. Similarly, a 27 here, 10, 10, 9, 9, and 3 and 3. Therefore, our final answer is 4.
Hello class, today we're going to learn about dimensional analysis. Dimensional analysis is a method to find relationship between quantities. By using dimensional analysis, we can convert from unit to unit. Let's start with a basic example. How many seconds are in a year? We start with what we know. 1 year is equals to 365 days. So we put 365 days on the top, and we line up 1 year in the bottom. At this point, we can cross out the year, and then we can convert from year to days. Next, we go from days to hours. We know that in 1 day, there are 24 hours. So we cross out the days. Now we use 365 times 24. We know how many hours there are in a year. Then we go from 1 hour to 60 minutes. And then similarly, we go from 1 minute to 60 seconds. So we can cross out the minute, cross out the hour. Now we use 1 times 365 times 24 times 60 times 60. Then we have the final answer, which is 31,536,000 seconds in a year.
Hey guys, now we'll move on to metric prefixes and their role in dimensional analysis. You need to know these metric prefixes to be able to solve problems that require you to convert between metric units. So here are the most common metric prefixes that you've already probably seen before in biology. 10 to the 9th is giga, 10 to the 6th mega, 10 to the 3rd kilo, 10 to the 2nd hecto, just 10 to the 1st deca, 10 to the 0 is just the unit itself, 10 to the negative 1st is deci, 10 to the negative 2 is centi, 10 to the negative 3 is milli, 10 to the negative 6th is micro, 10 to the negative 9th is nano, and 10 to the negative 12th is pico. So here we have, it would make your life easier if you just memorize these metric prefixes, and it's really important for dimensional analysis. So here's a simple mnemonic to help you guys remember some common prefixes. So the mnemonic is King Henry died drinking chocolate milk, and that stands for kilo, hecto, deca, deci, and centi, and milli.
Let's use what you've just learned to solve some problems. So here's the first problem we're going to solve. Convert 3 kilometers to meters. As you can see, there are 10 to the 3rd or 1,000 meters in a kilometer. So to solve this problem, we need to multiply 3 kilometers by 1,000 to get the number of meters. And that would give us 3,000 meters. And note how the units cancel out. This will become important later. Now let's try another problem. There are 18.02 grams of a substance. Convert this number to milligrams and express your answer in scientific notation. You may pause the video now to try this problem. So for this problem, if you look at these prefixes, there are 1,000 milligrams in a gram. So 18.02 grams times 10 to the 3rd milligrams over grams. So we need to cancel units. and this will become 1.802 times 10 to the 4 milligrams, and that is the answer. Now let's look at a harder problem. How many nanoliters are there in 2.435 milliliters of water? Pause the video to solve this problem. So in order to solve this problem, we need to convert from milliliters to liters to nanoliters. As you can see, the units cancel out and we would end up with nanoliters. There are 1,000 milliliters in a liter. Looking at our metric prefixes, we know that nano is 10 to the negative 9, so there are 10 to the 9 nanoliters in a liter. We started off with 2.435 milliliters, so when we multiply all this out, we will get 2.435 times 10 to the 6 nanoliters as our answer.
Now, let's explore the concept of density. Let's say, for example, we have a beaker full of water. And to this beaker, I'm going to add some salt. Now, the more salt I add, more salt is going to enter the solution, which is now a mixture of both water and salt. Eventually, as the salt begins to dissolve, there are going to be tiny particles of salt spread out as evenly as possible throughout the entire liquid. This brings up the concept of density. Density is known as the amount of matter in a given space. So, if, for example, I had a beaker full of 5 milliliters of water, and to that I added 5 grams of salt, I would therefore have a density of 5 grams over 5 milliliters, which is equal to 1. The density would be 1 gram per milliliter. Now, let's look at some problems with density. Let's say I have 5 milliliters of a solution with a density of 3.7 grams for every 1 milliliter. Now we're going to try and find how many grams of solute or dissolved material are in this solution. Alright, so first let's begin with what we know. We have 3.7 grams for every 1 milliliter, and we have 5 milliliters of the solution. Here, we can cancel out similar units. Milliliters cancel, leaving us with 3.7 grams times 5. And we can therefore find that there are 18.5 grams of solute or dissolved material in this solution. Now let's try a few more problems with density. Let's say we begin with 24 grams of salt. They're going to be dissolved in 5 milliliters of water. And we're going to try to find the density of the solution. Since density is the number of grams per milliliter, and we have each of these components, we can therefore find the density of the solution. So we know there are 24 grams of salt to be dissolved in 5 milliliters of water. By dividing 24 by 5, we can therefore find the density is 4.8 grams per milliliter.
Finally, let's say that we have a solution with a density of 11 grams per milliliter. If we know that we have a solution that contains 15 grams of solute, or dissolved material, we can find out how many liters of solution we have. So for every 1 milliliter of solution, we have 11 grams of solute. Now we multiply the 15 grams by 1 milliliter per 11 grams to find out how many milliliters we have. We can cancel out the grams and find that we have 1.36 milliliters of solution. So now, a helpful hint if you forget the conversions between density, volume, and mass. So we draw the circle here, put mass on top, draw a line, density here, and volume. So density equals mass over volume. Volume equals mass over density. And density times volume equals mass.
Now that you know what dimensional analysis is, check out our Jeopardy link for some extra practice.
And once you've got the concept down, take our quiz to test your knowledge. The results will be sent to us.
Thanks for watching!
Bye.